Welcome to my channel Ganit Matrix. My mission is to help engineering students to master the complex mathematics through clear step-by-step solutions. If you are preparing for engineering maths courses for universities like JNTUH, JNTUK, JNTUA and another competitive exam IIT JEE, you are in the right place. Now I specialize in breaking down the complex exam problems into clear step-by-step solutions, so you can walk into your exams with total confidence. And this is change of order of integration problem series, problem number 6, and the previous 5 problems links are given in the descriptions, so you can watch and share these videos to your friends. Now coming to the problem, evaluate the following double integral by changing the order of integration. Integral 0 to 1, integral x to root of 2 minus x square, x by root of x square plus y square dy dx. Since the inner integral corresponds to y varies from x to root of 2 minus x square. Outer integral corresponding to x varies from 0 to y. So outer limits are x varies from 0 to 1, inner limits x to root of 2 minus x square. Now the boundary of y, the upper limit of y, the boundary y equal to root of 2 minus x square corresponds to the circle. Now if you take the squaring on both sides, so y square equal to 2 minus x square, that means x square plus y square equal to 2 represents a circle with center 0, 0 and radius root 2, and the boundary y equal to x is a diagonal line through the origin. Now if you change the order of integration, the dy dx becomes dx dy. That means first we integrate with respect to x. That means we will take horizontal strip. If we are first integrating with respect to x axis, so we will take horizontal strip. Now if you want to find out the limits, just we draw the horizontal strip through the region and identify where this strip enters the region and where this strip leaves the region. Since it enters at y equal to x equal to 0 and leaves at 2 exit points, listen carefully. So here one exit point x equal to y, if you draw the horizontal strip here, and one exit point x equal to root of 2 minus y square if you draw the horizontal strip here, and that means one entry point but 2 exit points. So that is the region. We are dividing this region into 2 subregions. One is below the line y equal to 1 and the another region is above the line y equal to 1. So in each region we will find x and y limits. That means, so we are subdividing this region into 2 regions, R1 and R2, and we separately make the integrals for R1 and another separate integral for R2. Now how to find the limits? Since dx dy, that means x limits are functions of y and y limits are constants. So to find the limits, we draw the horizontal strip in the region 1 and identify where this strip enters the region and where this strip leaves the region. So it enters at x equal to 0 and leaves at this line x equal to y. So x varies from 0 to y, and y limits are from 0, the lower boundary, and 1, the upper boundary 1. So y varies from 0 to 1, x varies from 0 to y is the limits corresponding to region 1. Now how to find the limits corresponding to region 2? Same thing, draw the horizontal strip to the region and identify where this enters and leaves the region. It enters at x equal to 0 and leaves at since x square plus y square equal to 2, x square equal to 2 minus y square, therefore x equal to plus or minus root of 2 minus y square, but this is in positive quadrant, the first quadrant, so we will take x equal to root of 2 minus y square. So x varies from 0 to root of 2 minus y square and y varies from 1, and actually the maximum radius is root 2, so y varies from 1 to root 2, 1.414. So y varies from 1 to root 2, x varies from 0 to root of 2 minus y square is the limits corresponding to region 2. So our region is sum of two integrals. The first one is this integral 0 to 1 0 to y x by root of x square plus y square dx dy plus second region integral 1 to root 2 root of 0 to integral 0 to root of 2 minus y square x by root of x square plus y square dx dy. Now how we are evaluating this? First we are evaluating this inner integral x square x by root of x square plus y square dx. How we evaluated this? So the process is here. So to evaluate the integral root of x by root of x square plus y square, we are using the substitution u equal to x square plus y square. Differentiating u with respect to x, we will get du by dx equal to x, du equal to 2x dx. That means x dx equal to 1 by 2 du. Substituting in the integral, what it becomes? X square plus y square replaced by u, so denominator becomes 1 by root u, x dx becomes 1 by 2 du. So this is integral 1 by root u into 1 by 2 du. So 1 by root u means u power 1 by 2. If it comes to the numerator part, u power minus 1 by 2 du. Now apply the power rule of integration, integral u power n du equal to u power n plus 1 by n plus 1. Here n equal to minus 1 by 2. So this is u power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. So is u power 1 by 2 by 1 by 2. So 1 by 1 by 2 is 2, 2 to cancel, u power 1 by 2 root of u plus c. But u equal to x square plus y square. So finally we will get square root of u means x square plus y square plus c. So finally this integral, the inner integral after integration becomes root of x square plus y square. Same for first integral and second integral. But for the first integral the limits are 0 to y, in the second integral 0 to root of 2 minus y square. So substituting the limits x varies from 0 to y, right, for this result. So we will get, of substituting the upper limit, this is square root of y square plus y square minus square root of 0 plus y square. What will you get? Y into root of 2 minus 1, which will be evaluated with respect to y between the limits 0 to 1. So root of 2 minus 1 constant, integration of y is y square by 2. Substituting the upper limit 1 by 2, so we will get root of 2 minus 1 by 2. Similarly, so for this result, here we will substitute the limits, x limits, root of 2 minus y square upper, x equal to 0 lower. So if you substitute this, you will get root of 2 minus y whole square, root of 2 minus y square plus y square, minus, substitute x equal to 0, root of y square, that is root of 2 minus y. So which will be evaluated between 1 to root 2 with respect to y. So integral 1 to root 2 root of 2 minus y dy. So step by step integration. So this is integral root 2 dy, root 2 dy means root of 2 y minus integral y square by 2. Substitute the upper limit minus the lower limit, we will get 3 by 2 minus root 2. Now combinedly add these values to get the total integral I. So if you combine that, square root of 2 by 2 minus 1 by 2 plus 3 by 2 minus root 2. So which is 1 minus root of 2 by 2. That means if you write the denominator 2 as root 2 into root 2, 1 root 2 cancel from both numerator and denominator, and the denominator root 2 is remained. So 1 minus 1 by square root of 2 is the final answer. Thank you.